Hello everyone, my name is Gajendra Deshpande and today I will be presenting a talk on security considerations in Python packaging. So in today's talk, I'll be briefly discussing about importance of secure package and vulnerabilities in Python package index, then Bandit for identifying common security issues in Python code, safety for dependency check, and semgrep for static analysis of the Python code. Then we'll discuss few general guidelines for secure coding practices in Python. Now let us first look at some statistics. So we know that Python is one of the most popular programming languages in the world. So there is an index called as TIOBE index, which actually ranks the programming languages based on their popularity. And in TIOBE index, Python has reached the topmost position, indicating that it's the number one programming language, which is the most popular programming language in the world. Of course, this is not the only one. There are some other surveys. Let's say, for example, Stack Overflow. In Stack Overflow also, Python has reached the third position. So 48.24% of the people use Python. And if you look at the first two positions, they're occupied by JavaScript and HTML and CSS. They are mostly predominantly used by web development. Now there is one more survey, that is GitHub's statistics on jitter.io. Now here also you can see that Python is ranked third in terms of number of active repositories. So this same popularity is causing the problem for Python programming language, because many hackers are targeting Python packages and they're injecting malicious code into the Python packages. Now let us see open source and some security issues associated with open source software. So there is a general misconception about security of open source software. The main reason people cite is that code is open source. But if we look at the architecture of open source softwares, they are generally secure. That's because a very large team of volunteers will be working on the software and continuously they are making it better. So security issues are mostly due to lack of understanding of secure coding principles, and Python is generally secure, but the vulnerabilities may be present in packages. This is true in case of any programming language or any software which is open source. So Python is secure, WordPress is secure, Joomla is secure, but the vulnerabilities may be present in their packages, which are mostly developed by third-party developers. So either they are unaware of security practices, or the malicious code is being injected purposely. Now let us discuss the importance of secure package. So insecure package will make your application vulnerable and prone to external threats. So compromised and unauthorized disclosure of information may result into personal and company reputation and money. And many times unsecure code may damage the systems of the users. Sometimes it may also lead to the physical damage. Now In this slide, you can see that there are some articles which are written and which majorly highlight the various flaws and different malicious codes injected into the Python packages and which are listed in Python package index. So the first one, dependency confusion attacks, were mounted via PyPy repo, and it exposed the flawed package install behavior. So this article was published by a Portsfigure, which is well-known security company, which has a tool called as burp suit. Then JFrog had detected a malicious PyPy package stealing the credit card details and injecting the malicious code. Then vulnerabilities were found in the PyPy index repository. Then there is a block written which highlights the remote code execution in PyPy. Then supply chain flaws have been found in the Python package, and so on. So these are the few listed issues, but there are many more. Now let us discuss some tools. So the first one is Bandit. So it's a tool designed to find the common security issues in Python code. To do this, Bandit processes each file, builds an abstract syntax tree from it, and runs appropriate plugins against the abstract syntax tree nodes. Once Bandit has finished scanning all the files, it generates a report. You can install Bandit by using a pip command. You can just say pip3 install Bandit, and you can install Bandit on your machine. Now let us discuss how we can use Bandit, what's the command, and what are the different options available. Now if you want, you can run Bandit against a project code. For this, you need to specify the code path. So this code path can be local or remote. It can be even GitHub repository. So to specify the code path, you need to use -r switch or -r switch. Then you can also run Bandit with some specific profile. So by profile, we mean that we are going to check for particular vulnerability. So in this example, we want to check the Python code against shell injection profile. So we want to check for shell injection vulnerability for all files which are present in examples directory. Now to specify a profile, you need to use -p switch. Then you can also run Bandit with standard input. So we are using cat command to display the output of imports.py file and send that output to Bandit command. Now Bandit allows specifying the path of a baseline report to compare against using the baseline argument. Now you can specify the baseline argument by using a -b switch and specify the baseline keyword. And you can also specify what's that baseline. Now this is very useful for ignoring the known vulnerabilities that you believe are non-issues. Many times these are also warning messages. You can ignore them. Sometimes you will be using the package or source code for testing purpose. Say, let's say for example, in unit testing, you don't want to display the password in password using a special character. You just want to display the password using plain text. So in that case, you can use baseline and ignore it. To generate a baseline report, simply run Bandit with output format set to JSON and also specify the output file path. Now Bandit also allows you to write the custom tests. To write a custom test, to write your own test, you have to first identify a vulnerability to build a test for and create a new file in the examples folder or in any other folder you want to check your code that contains one or more cases of that vulnerability. Then consider the vulnerability you are testing for and mark the function with one or more appropriate decorators. So you can use @checks call or @checks import and import from or @checks string depending on your requirement. Then create a new Python source file to contain your test. Then the function that you create should take a parameter context, which is an instance of a context class. You can query for information about the current element being examined. You can also get the raw abstract syntax tree node for more advanced use cases. Then extend the Bandit configuration file as needed to support your new test. Execute Bandit against the test file you have defined in examples folder or in any custom folder and ensure that it detects the vulnerability. If it doesn't detect the vulnerability, you have to modify the test. Then consider the variations on how this vulnerability might present itself and extend the example file and the test function accordingly. Now Bandit comes with some plugins and these plugins are grouped into certain categories. Say for example, B1 series consists of miscellaneous tests. We'll see what these miscellaneous tests and other tests on the next slide. Then B2 series deals with application or framework misconfiguration. Then B3 series deals with blacklists which are related to calls, and B4 series deals with blacklists which are related to imports. B5 series deals with cryptography plugins. B6 series deals with injection plugins, and B7 deals with the cross-site scripting plugins. So on this slide, you can see that there are some test plugins which are displayed under each category. Say for example, in B1 series, I had discussed that it contains a miscellaneous test. So what are those miscellaneous tests? They are setting the bad file permissions, checking whether hard-coded password is a string, checking whether hard-coded password is a function argument, checking whether the password is default. Then similarly, if you consider B2 series, then you check whether the Flask debug is set to true. So this is very important parameter. So when you are developing a software, you can set the debug parameter to true because you want to know what are the errors, where is the error, and how to deal with it. But once your software is developed and when you deploy it, this flag must be set to false. Otherwise, hackers can use the same thing and they may discover the errors. And errors are mostly system generated. And when they are system generated, they usually reveal some information about the system. That means the server, maybe version of the operating system, version of the browser, and so on. Then in B5 series, you are going to check or deal with certification errors. That is, SSL is a certificate which is basically used for transmitting the data in encrypted form over the network. So here you're going to check whether SSL's bad version is set, whether SSL has bad defaults, whether no version is mentioned. And there are some test plugins which are related to weak cryptographic key and so on. In B6 series, you have some test plugins related to shells. And in B7 series, you have got some test plugins related to Django, whether it is marked safe, whether make templates have been used, and so on. So depending on your requirement, you can use the plugin and test your application for a particular vulnerability. The next tool is safety check. So safety checks your installed dependencies for known security vulnerabilities. So by default, it uses Open Python vulnerability database called as SafetyDB, but can be upgraded to use PyUp.io's safety API using the key option. It supports Python 3.5 and above versions. You can install safety command or safety package by using a pip command. For demonstration purpose, you can also install insecure package just to ensure that your safety package works fine. Insecure package is a package which is created just to test the safety command. It is an intentional insecure package. It does no harm. Now to check the currently selected virtual environment for dependencies with the known security vulnerabilities, just run safety check. Then you can also run safety check against the requirements.txt file. So generally this requirements.txt file will be having list of Python packages. Then you can also read the input from the standard input. So cat command is displaying all the commands listed in the requirements.txt file, and the same is given as input to safety check. Then you can also use pip freeze command. So in pip freeze, what we do is we are going to check all the packages which are installed using pip command in the current virtual environment. Then you can also check for particular package by specifying a package and supplying that package name as an input to safety check command. Now this is how you run the safety check command. So you just say safety space check, and it's going to display all the packages along with the versions installed and also along with the affected package versions. Now on this slide, you can see that it's showing the output of same command, but in this case, it is also displaying that insecure package is also installed, and it says that it's 0.1.0 version is installed, and any version below 0.2.0 is insecure. Then SafetyDB is a database of known security vulnerabilities in Python packages. The data is made available by PyUp.io and synced with the repository once per month. Most of the entries are found by filtering CVEs and change logs for certain keywords and then manually reviewing them. Now the important point is that the list is not the denial list or the package to be avoided. So that is just because it is appearing in the SafetyDB, it doesn't mean that you should avoid it. It means that you can use it with caution. So you can install SafetyDB by using pip command. Now, if you want to know the list of all insecure Python packages, then just visit the link which is mentioned. So it is the first link, that is pyup.io, pyup.github.io/safety-db. Now, there are two files which are provided by SafetyDB. One is insecure.json, which just contains the package name and all the insecure releases in the plain list. And insecure full.json file, it additionally contains the CV description and URLs and also the relevant part of the changelog. If you want to use these two JSON files in your program, you can import them and start using the respective JSON file. Now SafetyDB also comes up with some tools. So first one is the Safety CI. It's a deep GitHub integration that's available on pyup.io, and it checks your commits and pull requests. It basically checks for continuous integrations. Then safety, as we have seen, it's a command line tool that checks virtual environments and requirement files either locally or on a CI server. Then safety Django is a package for Django that warns you in admin area if your installed Django release is insecure. Safety bar is a macOS menu bar application which is in just alpha stage. Actually, it is not doing much. Then there is something called as pre-commit. It checks your Python dependencies against the SafetyDB. Then PPNV check relies on safety and SafetyDB to check for known vulnerabilities in the logged components. Then the last tool which we are going to discuss is the semgrep, which is open source static analyzer. It's open source and works on 17 plus languages, including Python, Go, Ruby, TypeScript, and so on. It works with legacy languages. It's not vendor controlled. 1000 plus rules have been written by the community. It enables you to write your own rules. That's a beautiful feature. And rules look like code. Then results are available on terminal or on editor or on a CI/CD pipeline. It also addresses OWASP top 10 issues such as SQL injection or broken access control, broken authentication, insecure deserialization, and so on. Then it eradicates classes of bugs by enforcing code guardrails at every stage of the development workflow. Then it hunts vulnerabilities by iteratively exploring a code base with lightweight queries and REPL workflow. Now on this slide, there is also one more link which is mentioned. That's a playground link. You can just click on the playground link and you can see that live interactive demo is available. So no need to install it. It's available live. Just select the language, then select the rule and select the code and just run. It will show the matching code. Now finally, let's discuss some general guidelines. If you are a package maintainer, then ensure that the package you are maintaining is secure and practice secure coding. As an application developer, follow secure coding principles while writing code. Then use tools to check vulnerabilities before using them in your projects. Then periodically scan your environment for vulnerabilities, that is before upgrading and also after upgrading and updating. Sign and verify packages using PGP keys. Then use Twine for improved security and testability. Then scan packages before upgrading. Then ensure that you install code from a trusted source or the official repository. Thank you everyone for attending my talk. If there are any questions, we can take it offline. Thank you.